Hello guys, so I'm back with the corresponding aspect of the geometry and what we beautifully get out of normal equations. So let's go back to what we did in normal equations. In this, remember we got these two estimates, right? These are the normal equations. So let's write the equations once again down. Summation of I from 1 to n, yi minus beta naught minus beta 1 xi is equal to 0. And we also got summation of 1 to n xi into yi minus beta naught minus beta 1 xi is equal to 0. Okay. So remember, solving with this, we got what? We got beta naught hat and beta 1 hat. So this two beta naught hat and beta 1 hat also satisfy this equation, right? All satisfy this equation, right? So what do we get out of this? So let's define something before that. Let's define summation of yi minus yi hat. So what is yi hat? So what we are trying to do, we have yi, we are trying to estimate in terms of beta naught hat plus beta 1 hat xi. Okay, this is a yi, and there's a remainder residual part. So this is not epsilon I. Okay, so you can sort of ei as a sort of so actual equation was this: yi equal to beta naught plus beta 1 xi plus epsilon I. So we're estimating this beta naught and beta 1 by beta naught hat, the best possible case by minimizing least square beta 1 hat. This ei and epsilon I, this is sort of not a realization exactly, but you can understand it's sort of a realization. Okay, there is the realization, sort of like it's not actually the realization. You have to understand that very carefully because yeah, so because we don't know this beta naught and beta 1, so we can't tell the realization. So we are sort of estimating this sort of the realization, sort of an estimate of the errors. Okay, not realization, but estimates is a good choice of word. So let's call this yi hat to be beta naught hat plus beta 1 hat xi, and we have this yi. So let's call this let's call this one, let's call this one ei, the residual. These are called the residuals. Okay, and yi hat beta naught hat plus beta 1 xi, beta naught 1 hat xi is the yi hat, the predicted yi, and this is the residual. So essentially we are trying to see that, we're trying to observe that yi is equal to y1 hat plus ei. Okay, this is a basic part. So this is what we have got till now, the whole thing we have got till now. Okay, there's a normal equations part. Very good. So now what's next? What do we have in the next part? Let's try to observe that, as I have promised you. So what do we see the interpretation as? Let's observe it very carefully, guys. So we got summation of ei. This tells that it's yi minus yi hat is equal to 0. So summation of ei, this sort of tells you the summation of ei is equal to 0. And this sort of tells you the summation of 1 to n xi ei is 0. These are two very important results. So this sort of implies that E bar is 0. And what does this imply? It implies the summation of xi minus ei minus E bar x bar. Since E bar is 0, this is 0. This is 0. And what is this? 1 by n of this. Is S of, as I define, not S, but yeah, you can understand this is sort of, let's not keep this 1 by n. If you know the relations, S of x comma e is 0, right? We have defined S before like this, right? In this manner. Essentially, therefore, we are getting that S of that xi, x comma e is 0, right? This is very important, very, very important aspect of this. E bar is 0, S of x comma e is 0. So let's revise what we have got the results out of this normal equation. We have got y bar because we know that beta naught hat plus beta 1 hat x bar equal to y bar, right? So what we got? the first result we got, let's write down the results one by one. The first result we got that beta y1 hat is equal to beta naught hat plus beta 1 hat xi. We also got that y bar equal to beta naught hat plus beta 1 hat x bar. This is important. Sort of this implies, this is the implication that the regression line, the line we have got, passes through x bar comma y bar. This sort of implies this. And what else we get? Let's explore. We got that e bar is 0. We also got that s of x comma e is 0. Okay, e comma x and x comma e is sort of the sample covariance of errors and x are 0. Now we will prove the following results soon. Okay, let's me write down the results. We'll prove that y hat is and e is 0. So the y hat is only dependent on x. It's like just a linear in x, right? So therefore we'll see that y hat and e, the covariance is 0. We'll also see something really interesting, that s of e comma y is actually equal to s of e comma e. That's really interesting because y can be divided into y hat and e, right? Now y hat and e has covariance 0. Sort of we'll see that this is sort of something related to Pythagoras theorem. Okay, I love this one to explain to you. Everyone I have explained in my life, the students of mine, the whatever, my friends, I love this one because of geometric interpretation. Once you understand geometric interpretation, everything, each of these results becomes super easy and very with much more clarity. Okay, what else we get? We else also get the following. This will not prove that s of y hat is equal to r square s of y, s of e comma e is equal to 1 minus r square s of y. What is r? That's the big question. R, we can define it as s of xy by s of xx, s of yy root over. Okay, I will come to this why this suddenly occurs, okay, in the next video. But remember this one. Okay. I will come to this, that how the correlation regression comes up together. Okay, where what does naturally arise? What do we mean by regressing towards a mean? That is the basic idea of mean, the simple linear regression, right? So we'll slowly understand this. So also this implies that s of e comma e plus s of y hat comma y hat is sort of equal to s of y comma y. That's really intriguing for me. It's sort of the, we will see that this is sort of Pythagoras theorem. This is a Pythagoras theorem of statistics, of simple linear regression. So these are the basic results we have seen. So we have proved this one, we have proved this one, we have proved this one from the first normal equation. We have done this one from the second normal equation. So let's now see these two properties and why these are so natural. Okay. So let's go back to the results and the proofs. So what we have got? So we have got e bar is equal to 0. We have got sx of e is equal to 0, right? We want to prove that s of e comma y hat is equal to 0. Why this is 0? What is y hat? Y hat is equal to beta naught hat plus beta 1 hat x yi hat, say xi, right? What is this s of this? Let's not write equal to 0. Let's try to write it down. It's summation of 1 by summation of n 1 to n yi hat times ei hat minus e bar, what I'm writing, I'm so sorry for this, yi minus e bar into the mean of this, right? So let's not go into that mean, okay, because this is already 0. We know e bar is 0. So it's equal to summation of 1 to n beta naught hat plus beta 1 hat xi, sorry, into ei. If you just sum it up, guys, it's summation of 1 to n beta naught hat, because beta naught hat is constant, into ei plus what? Actually, it will be n into e bar, okay? So every time I'm doing that mistake, it will be n into e bar here also. Okay, but I have done that x of x will be n into e bar. Anyways, so let's come to this point. Plus beta 1 hat is also constant, summation of xi ei 1 to n. So observe that from a second. So this is the ace of e comma e, right? Ace of x comma e, right? And this is 0, and this is e bar sort of n into e bar. So this is also 0, right? Summation of ei is 0. So this comes from the first normal equation, this comes second normal equation. Sort of, it means that y hat is only dependent on x and e sort of has covariance 0. So therefore y hat and e has covariance 0. It's very natural. Okay? Very good. So we got the second one also. How do we get this one? S of e comma y. It's very easy. So s of e comma y, you can write it as s of e comma y plus y hat. Y is equal to what? Y hat plus e, right? So you can write it as y hat plus e. Okay, and sort of you can understand it's sort of covariance of e comma y hat plus e. The covariance of y hat and e is 0. Sort of it means that it's covariance of e comma y hat plus covariance of e comma e. Sort of this is 0. This is covariance of e comma e, which is equal to s of e comma e. So we get that s of e comma y equal to s of e comma e. Okay, and we got this second result. Now comes the third result, that y hat s of y hat is equal to 1 minus r square s of yy, and s of ee is sort of r square into s of yy. So I will not explain the proof of this, but I will explain the geometrical idea behind this, what is why it is true. So we will see in the next video that r square is actually less than equal to 1 and greater than equal to 0. Sort of the correlation measure, okay? Sort of how two variables are linearly related. And we will get that idea that, so this is the geometrical idea behind it. Sort of r, you will see r, it will be sort of actually -1 to +1, this is cos theta. So if you have this vector v, okay, so v cos theta is actually, or rather this distance r cos theta is this, and r sin theta is this. Okay, you know this, right? If this length is r, you know this. This is a basic high school geometry. So now, similarly, what we'll do is that if we'll observe that this is s of, so if this, so therefore this square, if this is r square, it will be r square cos square theta, it will be r square sin square theta. I'm just taking the square of it. So this length is actually s y y. This is the y vector, okay? The y actually. This is the s y hat. Sort of we are projecting y to y hat, the best possible on like projection on x-axis, okay? On the x variable. This is the x bar comma y bar. This is a bit hard to understand if you are doing it for the first time. And this is s of e comma e, the error, sort of error. And so this is the idea, this y, this is the y hat, and this is the error. You can understand from here that the error is perpendicular to y hat. That sort of gives the idea that s of e comma y hat is equal to 0, similarly. And that is the main idea, okay? S of y comma y hat is 0. And this is a basic beautiful idea out here that you can understand from here that s of y hat will be what? Projection of s of y, right? And we have told that its r is actually cos, so it will be into r square, s of y into r square. So that's a basic idea. So that's the basic idea. Yes. That's the basic idea, what we are getting. And therefore, s of e comma e, am I doing it right? Oops, so it will be 1 minus r square, I guess. So it will be sin theta or something like that. So essentially you got the idea, essentially. So this is the 1 minus r square, and this will be r square into syy. Have I? I am wrong. So this is, yeah, I have done it correctly before. So y hat is actually r square. Y hat is actually r square, and this is actually 1 minus r square. And it makes sense. This is actually cos square theta. Yes. Essentially it's r square is this, because this is r square sort of, r is sort of cos theta, remember this, and this is 1 minus r square. Then what is happening over here, guys? Essentially what is happening is that you can understand what this means, that s of a comma b is actually sort of summation of ai minus a bar times bi minus b bar, right? What does this look like? If you take this vector a1 minus a bar, a2 minus a bar, dot dot dot, an minus a bar, and if you take this vector b1 minus b bar, b2 minus b bar, dot dot, bn minus b bar, you understand that this is sort of the dot product of these two vectors, okay? And that's why essentially everything is coming up like this, right? Everything is this. So y is sort of the y1, y2, y1 minus y bar, dot dot dot, yn minus y bar. This is sort of the y1 hat minus the average of that, and it goes on, okay? And this is the error part, e1 comma e2. So essentially everything is perpendicular to each and every one. So this is a basic idea. This is a very beautiful idea of this, that why these are two sort of perpendiculars, and why this we got summation of the dot product of, that means dot product of e and y hat, summation of ei and summation of yi minus yi hat is actually yi hat minus that mean is actually 0, and that is what is expressed by x and y, e comma y hat, right? That is a basic idea. So remember this geometrical aspect. This is a very beautiful aspect which I love it. I'm sure you will love it if you understand it very carefully. In the next video, I will come back again with the ideas of correlation and how correlation is related to the regression, and it's called regression towards a mean, and why correlation is less than equal to 1 greater than equal to minus 1. Like correlation behaves like cos theta. Okay. I hope you enjoyed this video. See you in the next video. Stay tuned. Stay blessed.